So yeah, a good welcome from my side as well. Again, I'm Philipp Slusallek from the DFKI. Actually, if you want to know more about the DFKI, it's right next door. And I'm going to talk about one part of FIWARE, which is specifically dealing with 3D applications, what we call the advanced 3D user interface of FIWARE. So you all know what web pages typically look like today. Right here, I've just chosen more or less randomly a web page that deals with a protein database. It's a very famous website among scientists, and it looks like any other website, right? There's a lot of text, there's a couple of images all over the place, right? But molecules are not just text. Molecules are not just shown by images, and so wouldn't it be much easier? Actually, the 3D structure of molecules is really important to understand the functionality, right? So wouldn't it be great if this web page here, instead of just giving you this small, tiny image there of this molecule, if we could have a 3D molecule right there, you could be immersed in this molecule, you can inspect it, you can fly through the molecule, you can inspect its chemical properties, its physical properties, link to databases about special parts of the molecule, and so on. This is just one example, and it's not possible really, or in theory it's possible, it's extremely difficult to build a interactive 3D website like this. This is just one example. So what about you want to configure your new car, right? So again, this is important. The look of a car is important. You want to try out, you want to open doors, try out different accessories and so on. Again, this is really hard to do with today's technology, and FIWARE, the advanced user interface part of FIWARE, makes it rather simple to do that. Or you want to buy a new camera, right? And you want to inspect the different parts of this in your website already. Or you want to visit a museum, and you could do that already interactively in 3D just by sending someone a link, right? You click on the link and you're right in the middle of that museum. You can inspect the different parts and so on. Or you actually want to do virtual tourism. This is actually a church from the Olu 3D project. And as you can see, there's a couple of avatars, users, think like Second Life style application, but not just linked to just doing Second Life, but much more general functionality that you as a developer could actually put together. And funny enough, in this church, they actually had a virtual church service on this church. So you could even do that if you want. So what is this advanced 3D user interface technology that I'm talking about here? It's really just the web as we all know it. Right? So the web today consists of the content, which is the HTML document, where the text and the images are linked. Then on the left-hand side, we have the style, which shows the layout of the scene, typically currently in 2D. And on the right-hand side, we have the interactivity described in JavaScript, the interaction. And we're keeping all of this exactly the same way, except that in the content side, we add a couple of new tags to HTML5 to allow us to describe 3D objects, animations, changes over time, but also processing on 3D data. And you can see all of this in our demo, so I will not show much interactive things here, but refer you to the demos later on. So what is XML3D? Is the core technology of this part. As I said, it's an extension to HTML5. It's a high-level scene description. So if you're not a graphics expert, but you want to have interactive 3D application, XML3D is exactly for you. You can just say, here's a 3D object, please rotate it on. If you click on the object, this is what should happen. This is the style of programming that web programmers are very familiar with. You see an example here, so it's really part of the HTML page. Here we say, okay, here an XML3D object starts. Here's an object, we can have a shader, and we can also use the on-click or on-mouse over events that every web developer, and there are millions of them, are very familiar with, and we can apply that to a 3D object, for instance. So it actually looks very simple. And then for the content, we actually refer to some some resources, a 3D object, an animation, a shader, and other things. We reuse all of the standard HTML technology like CSS, JavaScript, the DOM events from HTML. And that together then XML3D offers a lot of features, a very flexible and compact 3D scene format. For the first time, really part of HTML itself. We support animation, we support different kinds of geometry specifications. There's image processing for AR. Everything is, not everything, but a lot of the things are hardware supported using the GPUs, also working on mobile devices. We have a new, very powerful advanced portable material system, so you can assign optical materials like the textures and things to an object, and it will render both on the web browser but also in high-end visualization systems, and so on. So XML3D is kind of the core technology for getting 3D data into the browser itself, but that's not all. There's a lot of other functionality that we developed, or we are still developing partially, that augments that. So for instance, we have a synchronization server. So you don't want to just download the 3D content into one device, but you want to actually collaborate with others. You want to jointly play a game, and obviously if you change something in the game, then the other person should see that. So you need synchronization of changes between 3D scenes. And a Finnish company, Ludocraft, is working on that part. We have cloud rendering. So for some mobile devices, maybe a large model cannot be rendered on the device itself yet. So we can render it on the server and stream the resulting video to the mobile device. For dealing with real-world environments, we have a GIS server that provides GIS data, terrain data. We have POI, points of interest. So this could be a traffic sign, this could be a shop, this could be a house, lots of other things as well. They are provided, and then you can render this. It's very easy from those servers getting the data and putting them in the 3D scene. We can also capture the real environment and create 3D objects out of that, at least partially at this point. This is a hard problem. And then there's a lot of application-oriented functionality. There's actually an editor, 3D, what we call an interface designer to change 3D worlds, change animations. 2D user interface is part of that. Virtual characters obviously very, very important, because otherwise your scenes and your worlds are very boring. We can also interact with the real scene. So you have a virtual environment, and by clicking on an object on your mobile device, you can actually switch on the light, or change a machine, switch a machine on, or things like that. And augmented reality is really a key part of this all. So let me talk a little bit about the individual parts and this entire service infrastructure. So here, what I've tried to depict is this idea of really making the web browser the core element of interacting also with 3D content. Right? So we have the web browser. You send someone a link, he clicks on the link, the browser opens, and you're right in the center of the 3D environment. We can, as I mentioned, we have rendering services that could run on the server, on the local device, or in mixed forms. We can display in the browser, but we can also display on large devices. We have a display as a service that we provide here. Then in the browser, the application runs with all sorts of functionalities that we provide. But the really important part is the part on the left, right? We're already in the web. We can have links, URL to services using whatever communication technology. This could be a CAD system for getting the data. This could be an artificial intelligence engine that, for instance, directs virtual characters in the 3D scene. It could be I/O devices, the Internet of Things, high-performance simulation services, or other things. So for instance, one of the projects that we're working on at the DFKI over here is this kind of virtual characters in a industry environment, really being able to simulate characters, do predictions of how to organize the production line. And that's actually something we do together with large companies like Disney, like Daimler. We also work with Disney, but not on this, not on production lines. This is more on the gaming side, of course. So I'll quickly go through some of the technology that we're providing. So one company that is part of this consortium is the Adminotech, also a Finnish company, and you find them back there doing demos. They have an integrated 3D user and synchronization functionality that, again, you can connect to a server. All of the local changes will be synchronized to the server and will be distributed to whoever else is looking at the same scene, and vice versa. You get all the changes that other people are doing in the scene. All of this happens automatically, and we're merging this with the XML 3D technology right now. One of the topics we're currently working on, for instance, is physics. So you can have collisions and real-time interaction in this 3D scene as well. So here's a couple of examples. So the church that I showed before is exactly running in this environment. Here we have collisions. There's also code. So if all of this technology I'm talking about is open source, and so we took care to also provide tutorials and example scenes you can get started early. The 2D user interface is really about abstracting the access to devices like game controllers, touchpads, and all others. So this is an important part, but maybe not so eye-catchy here for Cebit. So let's go to the synchronization that I already talked about. It's this bidirectional real-time. The real-time is really important, but think about there's hundreds of users that actually want to work together. So that's a very challenging thing. We actually build on top of an existing tool, Tundra, and we're still compatible with this. We use what is actually used a lot in the game industry, a component, entity component model for doing the synchronization. It's very, very flexible and extensible. So if you want to put special data into your 3D scene, it's very easy to just get that synchronized as well. Right? It's not a closed source like Second Life, but you get to define what gets synchronized, what is in that 3D world, and how the 3D world behaves. But you could also do that for instance, collaboratively building a house, or designing a house, or working on a 3D object, and so on. All of that, you get to define this. This is the whole idea of FIPPP, not build closed applications, but build tools that you can then tailor and combine in a flexible way so you can build exactly what you want and not just take things from the shelf. So here is just an example, and actually that is also shown in the demo booth over there. So we have a large virtual environment, and we can have avatars, many avatars actually walking through that virtual environment in real time, and they get all synchronized. I mentioned cloud rendering already. Here you see an example of the Mesh Moon system in the lower right here, which renders locally, and the results of that are being streamed into a web browser that you see on the left here. And again, this is really important for two reasons: either that on the client device you might not have the rendering power for large scenes, or the other one is that you might not have the rights to distribute the 3D scene, but in many cases it's perfectly fine to distribute the video of the scene. So think about a new car model, right? Volkswagen or someone doesn't want you to have the 3D model, but they're happy to show you the resulting images and let you interact with it, but they will not give you the model. Augmented reality, again, we can show that in the demo scene. So here in this, what you see here is actually a YouTube video being streamed into the browser in JavaScript, and with partially with GPU support now. We're extracting this pattern in this case, and we're extending this to general image-based feature tracking. And this teapot that you see here is not part of the video, but it's rendered and positioned in real time on top of the video in the browser. On the lower left-hand, so you see the kind of the structure. So you see the XML 3D at the bottom, the scene management, and on top of that we have the augmented reality processing. So this works on a YouTube video, but if you activate your local camera or a USB camera in your mobile device, you can do the exact same AR tracking that we're showing here in this video, in this YouTube video case. It's just a very generic technology. You can use that together with XML3D, but you can also use it alone, or you can tailor that to whatever kind of applications you want to apply. You get to choose which modules you want and you need. Real virtual interaction is really the next thing, right? Now we have augmented reality. We see switches, we see machines, and you want to interact with the machines. These machines today, which is called the Internet of Things, they provide ways to access the device, to operate the device, to provide sensor data or the state, the data about the object is in. So you want to visualize the state of the object. You want to offer capabilities of changing things, switching on lights is the common example here. But you can do much more advanced things as well. So what you essentially create is what a lot of people call dual reality, right? You have the real world out there. You have a virtual replica of the real world in your device, but whatever changes in the real world is being reflected, is also changed in the virtual world, and if you make changes to the virtual world, they're being sent to the real world and the machines are switched on and off and whatever. So again, it's a separate module. You can combine it with augmented reality. You don't have to, but it often makes a lot of sense. So all of that is available to you. You'd get to decide. The geographical information system, again, it's a service that provides layered selectable geographic data to clients. You could use that to do whatever with the data in your application, but we designed it in such a way that you can easily put it into an XML3D scene. And then, for instance, here, have the terrain, have the buildings being placed in this 3D world. You can walk through that. You can combine it with virtual characters to actually have people walk around in this environment, because we know what are streets, we know what are buildings, and so we can actually tell the avatars where they can walk and where they might not be able to walk. You can also combine data from different sources. Maybe you have one database that provides the terrain, you have a different database that has the new city planning data maybe that you want to visualize. For the German-speaking people, Stuttgart 21 would not have happened if you could have told the Stuttgart people what the new part, what the new city, what the new train station would have looked like. Maybe it would have changed the whole story. So here's example, and again, those examples are running at the demo in the back there, in the back far corner there. So this is also with 3D data, shaders on the water. You see the device information of a weather station here. That is a real weather station in Finland, and you can get the real data. This is also a demo that we show back there. It's kind of visualizing a virtual house. Let's say you want to buy a house. You can actually walk through the environment, walk through the house, look at the house from outside. You can sit in the living room and say, oh, what is my view? So all of this is being developed, again, at the University of Oulu. And it's running using the technology that I've been describing so far. Right? The point of interest data, I already mentioned that, enables you to do location-based services. Right? So you can have databases that provide information, and you can get the data. The data is in a format that you can very easily put in the 3D scene with a marker, with an image, together with an entire web page maybe. It can provide animated scenes, right? So you can have a person dancing in front of your shop, if that is what you want to do, for instance, to attract customers, or you can actually have an entire game that is being played, and that's actually what I will talk about in the next talk right after that, which is then part of the FI content project, which builds on top of what I'm talking about here. All of this data is available in RESTful APIs, and it's very easy to deal with these. So here again is an example. In this case here it's a 2D map in the top left, and then on the right hand side you see an example of using augmented reality in the environment with, in this case, some simple, really important beer connoisseur database. So you get to know where the best beer is in town, and you get to see that through your augmented reality enabled phone. I mentioned that before. Virtual characters are extremely important technology to kind of bring the entire scene to life. There's a we provide a JavaScript library. This is a screenshot that, again, we can show you back there of animated characters. There's a very flexible system for defining animations of those characters in the character model. We use skeleton animation here with hardware-supported skinning operations, so it's very efficient. You can have dozens of those characters even running in your web browser again. You need, a year ago or more, you needed a game engine to do that. This is just running in your browser without any plugins. That's the cool new thing, right? Send someone a link, and the whole thing just pops up right in front of the eyes in the middle of the entire interactive game here, for instance. Yes, and at the end, we have the interface designer. The interface designer is really, admittedly, it's not a full CAD system, right? Right now, it allows you to configure the 3D scene, move things around, change things, but this will be improved over time so that we have much more functionality. All of that, what I've been talking about, is an open source system. So what you can do is, if you want a better interface designer and you feel like you can do it, you can start with the source code that we provide and say, oh, maybe I want a special editor for my animations because I need to have some special needs there. Well, you can start with the code that we provide, build on top of that, maybe provide it back to us, and so people can, again, build on top of that. That's the whole idea. And for the first time, we're providing with this technology in FI content, sorry, in FIWARE, we're providing you ways of doing this interactive 3D graphics for the web browser directly. And what I haven't really talked about much is this integration with all of the other generic enablers or all the other technology. What I've talked about is one of the work packages in FIWARE, but there's all of the other for cloud hosting, for data management, large data management. There's lots of other stuff. Security is in there. And so the key thing is that you can, all of those modules, all of those functionalities are designed that you can pick and combine them in the way that you need for your applications. So it's really kind of a great set of tools that you can use to build your own applications. And the best thing that's been talked about earlier here is that the EU has been funding all of these activities here. Later this year, will distribute 100 million euros to companies and to individuals who want to build technology based on these functionalities that I'm talking about here. So if your company is interested, or you personally are interested in building something, you don't want to start from scratch and you actually want to get paid for that, there will be calls in the fall for applying. You can get up to maximum 150,000 euros, essentially for building your own application, for building your own company on top of that, if you want to do that. So with that, I'm kind of done. And yeah, if there's any questions, I'm very happy to answer them.
All right, Philipp Slusallek, thank you very much for your talk. Thank you. Yes. All right, so are there questions? Do I see questions, or do I have to, do I put my own? I mean, all right, so let's come back to the 100 million euro thing. So how can I apply? Who can apply? What visions are you looking for? What visions is the FIPPP is looking for?
So the way this works is a little bit indirect. The 100 million euros are currently being distributed to 16 different management projects. They just started working last week. And so they are organizing the distribution of the money, and each of the 16 projects will have a slightly different focus. Some of them will focus on big data. Others, there's a couple that will actually focus on this 3D technology, the gaming side, and general interactive 3D applications. Exactly which projects will do what is not, they're just starting like last week. So this is not known yet. Please watch out for the FIWARE pages or the FIPPP pages All of this will be announced after the summer. The exact timing is not clear yet.
And it's 100 million euros, and it's the maximum each could be 150,000.
150,000 euros per project,
Okay.
which is a lot of money to get started, right?
Yeah, for me it's a lot of money, but the young people, they dream of 19 billion, I guess. All right, so.